This is Algebra Lesson 10-2, Part 1, Quadratic Functions. In Lesson 10.1, we investigated the graphs of y equals ax squared and y equals ax squared plus c. We didn't have a middle term. In the quadratic function y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry. So let's take a look at three graphs here. In this first graph, we have y equals 2x squared plus 2x. And in the second graph, we have y equals 2x squared plus 4x. In the last graph, we have y equals 2x squared plus 6x. Notice that all three graphs have the same y-intercept. They are intersecting the y-axis at the same point. Right? If you notice, they intercept the y-axis. Right? We have a y-intercept right here, y-intercept right here, and here. And right here and here. Those 2 points don't change. It still crosses the y-intercept at 0, and it looks like -1. Okay. And it's okay. So when we look at this, we can clearly see that it doesn't change the way the graph is looking. What we do notice, though, is the asymptote changes. The line of symmetry, excuse me, line of symmetry changes. Asymptote is a term we use in Algebra 2. Right? Our line of symmetry, our axis of symmetry, okay, may move. All the three equations, c is 0. We don't have a c term. The axis of symmetry changes with each change in the b value. The equation of the axis of symmetry is related to the ratio. Okay? You can hopefully see that in each instance, the axis of symmetry, if we look at this, here's my axis of symmetry. Here, x equals -1/2, x equals -1, and x equals -3/2. So if you look at our original graph, x equals -1/2, right? If I take -2 over 2 times 2, I get -2/4, which is -1/2. That will be this one. And here, if I take -4 over 2 times 2, I get -4 over 4, which is -1. And in this last graph, I take -6 over 2 times 2. I'm going to get -6 over 4, excuse me, not 3, 6 over 4, which gives me -3/2. Okay? Which is related to this equation right here, which I'll give you in a better term. So, the graph of a quadratic function, y equals ax squared plus bx plus c, where your a term cannot be 0. It has a line of x equals -b over 2a as its axis of symmetry. And the x-coordinate of the vertex is -b over 2a. Okay, this is a very important concept, something that you should highlight in your notes. When you substitute in x equals 0 into the equation of y equals ax squared plus bx plus c, y will equal c. So the y-intercept of a quadratic function is the value of c. That is really important right there. That statement is very important. Okay? The y-intercept of the quadratic function is the value of c. You can use the axis of symmetry and the y-intercept to help you graph a quadratic function. And I'll explain how that works. Okay? We're going to graph an equation in the form of y equals ax squared plus bx plus c. And we're going to graph y equals 2x squared plus 4x minus 3. The first thing we should do is find the equation of the axis of symmetry and the coordinates of the vertex. Okay? To find your axis of symmetry, remember I just gave you that formula. The formula for the axis of symmetry is x will equal b, -b over 2a. So in this equation, remember, this is a, this is b, and this is c. If it helps, say a equals 2, b equals 4, and c equals -3. Sign those with numbers. So if I was to apply that, I have -4 over 2 times 2, which is -4 over 4, which is -1. Okay, so my axis of symmetry is x equals -1. That's my axis of symmetry. The next thing I need to do is I need to find my vertex. Okay? The coordinates of the vertex, if you remember, the x-coordinate of the vertex is the axis of symmetry. Okay? Okay, so in other words, the x-coordinate of my vertex is -1. So if my x-coordinate of my vertex is -1, to find the y-coordinate of my vertex, I'm going to substitute in -1 into my equation and solve for y. So I have the equation of y equals 2x squared plus 4x minus 3. I'm now going to substitute in -1 wherever I see an x. So I'm going to have 2 times -1 squared plus 4 times -1 minus 3. And what I will get, I'm going to just move this up here a little bit so I can actually work on it. I get -1 squared is 1 times 2 is 2, so that gives me 2 plus -4 plus -3. Right? Or 2 plus 4 minus 3. What's -4? So this gives me -5 as my y term. So my vertex then has the point -1, -5. The x value of my vertex is my axis of symmetry, and the y value of my vertex is the y value when I plug in my x value into the equation. So I now know that my vertex is -1, -5. Okay. Since this 2 here is positive, I also know that this is a minimum point. We learned that from yesterday's lesson, because if my a term is positive, it's a minimum point, so my graph's going to open upwards. So now I need to find 2 more points on my graph. That's my second step. I need to find 2 other points on my graph, because the y-intercept has 1 point. Okay? So I have 1 point. 1 point is my vertex is 1 point at -1, -5. Okay? And I can use my y-intercept as another point. Since my y-intercept means it's going to cross the x-axis at 0, okay? So I'm going to plug in x equals 0. So when x equals 0 into the equation, and remember I'm just going to rewrite this equation down here for a minute. Y equals 2x squared plus 4x minus 3. When x equals 0, y equals -3. So there's my y-intercept. Okay? So another point, the second point is my y-intercept, which is at 0, -3. Because if I plug in a 0 here, that becomes 0. If I plug in a 0 for x there, that becomes 0, and I get y equals -3. Now I just need to choose a different value for x on the same side of the vertex as my y-intercept. Okay? So I'm going to choose a positive number. I'm going to choose 1. Okay? So I'm going to let x equal 1. So I'm going to choose another point. I'm going to let x equal 1. So if I let x equal 1, y equals 2 times 1 squared plus 4 times 1 minus 3. 1 squared is 1 times 2 is 2 plus 4 minus 3. So 6 minus 3 is 3. So my other point is 1, 3. So when x equals 1, y equals 3. So my third point then is 1, 3. So I now have 3 points. I have the vertex, -1, -5. I have the point 0, -3, and I have the point 1, 3. So I can simply graph these 3 points, and I'm going to just draw them down here, -1, -5 is one of my points. 0, -3 is my other point, and my third point is 1, +3. Those are my 3 points that I'm going to graph on my graph. So now I'm just going to reflect my 2 points across the axis of symmetry to get 2 more points and draw my parabola. And so first thing first, let's draw my x and y axis. My x-axis, my y-axis. So I have the point -1, -5. -1, 1, 2, 3, 4, 5. That happens to be my vertex, which means my axis of symmetry is along this line. We like to draw axis of symmetry as dashed lines, okay, because it helps you be able to, because we're not reflecting it over the y-axis anymore, we're reflecting it across the axis of symmetry. So now my second point is 0, -3, so 0, -3, 0, 1, 2, 3. Here's this point. It is 1 unit to the right of the axis of symmetry, so its counterpart should be 1 unit to the left of the axis of symmetry. My last point is 1, 3, so 1, 1, 2, 3 is here. That is 2 units to the right of the axis of symmetry, so I have to go 2 units to the left of the axis of symmetry for my other point, and now I can draw my graph. So this is the graph of y equals 2x squared plus 4x minus 3. Okay, let's do another one. Y equals x squared minus 6x plus 9. We're going to label the axis of symmetry, and we're going to label the vertex. So we're going to do a lot more labeling on this graph than we did on the last graph. So the first thing we need to find is the axis of symmetry. Okay, so my axis of symmetry is going to be x equals negative b over 2a. And if it helps, a equals 1 in this case, b equals negative 6, and c equals 9. So negative b, so negative 6 over 2 times 1, which is going to be 6 over 2, which is 3. So my axis of symmetry is 3. So when my vertex is, when my x value is 3, okay, what's my y value? Because I have to find my vertex now. And remember, to find my vertex, I now substitute in 3 for my x value and solve for y. So y will equal 3 squared minus 6 times 3 plus 9. 3 squared is 9 minus 18 plus 9. 9 minus 18 is negative 9 plus 9 is 0. So my vertex then is at the point 0, 3. It's 3, 0. I have that backwards. 3, 0. X value of my vertex is 3. The y value of my vertex is 0. There we go. So there's my vertex. So I have my vertex. Now I need some more points. Okay. So I can choose the y-intercept, but since the vertex happens to, well, I can just choose the y-intercept. That would work. Okay. So when x is 0 then, when x is 0, if I plug in a 0 for x squared, I get 0 minus 0 plus 9, so I get 0, 9 as another point. Okay. That's probably enough points to draw a fairly decent parabola here. We know it's going to open upward, so I know I need more points above my x-axis than I do below my x-axis. So here's my x-axis. There's my y-axis. We plot the vertex, which is 3, 0, 1, 2, 3, 0. My axis of symmetry is at the line of x equals 3. So here's my axis of symmetry. X equals 3. There's my axis of symmetry. So it told me to label the axis of symmetry and the vertex. My vertex is at 3, 0, so I'm going to label that point. And I'm going to graph 2 more points. I'm going to graph the point 0, 9. 1, 2, 3, 4, 5, 6, 7, 8. That's there. That happens to be 3 units to the left of the axis of symmetry. So now I'm going to graph its counterpart 3 units to the right of the axis of symmetry, which would be right there. And I can now draw my graph. Notice I only needed 3 points to draw this graph, because any more than this, I would probably run out of graph space. So this is the graph of y equals x squared minus 6x plus 9. You have to go through quite a few steps to be able to graph these. But the steps are not difficult. You just will have to learn how to do them. And let's take a look at some other graphs. Or maybe not. That was part A. That's right. That's all we need for part A in quadratic functions. So make sure you know how to graph your axis of symmetry, find your vertex, and graph at least one more point from that, and then you can graph your quadratic functions.